What is an overhaul? It is a series of operations comprising disassembly of a vehicle component, such as an engine, a transmission, or a carburetor, into parts, inspecting each of the disassembled parts, repairing or replacing the defective ones, and reassembling the parts into an integral component that provides the designed functions. In components with complex functions, such as engines, internal defects are difficult to detect from the exterior. Such components must be overhauled to locate and eliminate the defects. This video will show you the procedures and cautionary requirements for overhauling an engine, a vital part of the automobile. The 4AF engine model will be used as an example. This is the general flow of an engine overhaul. Before engine disassembly, it's necessary to understand the engine's condition. The engine must not be disassembled without first understanding any problems the engine has and which parts must be overhauled. After that, begin disassembling the engine. Each time you remove a part from the engine, inspect the part as to its assembled state, soiling, wear, flaws, etc. Removed parts should not be inspected all together after complete engine disassembly. It is essential that each part be inspected as it is removed. The disassembled parts must be arranged in order, sorted into those to be replaced and those to be reused. The disassembled parts may be soiled with dirt, dust, or grease and must be cleaned. The parts should then be reassembled following the procedures specified in the relevant repair manual. Specified tightening torques, adjustment values, etc. must be followed. Pistons, crankshaft, and other parts subject to combustion pressure must be lubricated with engine oil before they are installed. After engine reassembly, each part must be checked for normal function using an appropriate gauge or tester and adjusted if necessary according to the maintenance standards in the relevant repair manual. This checking and adjustment must be carried out after assembling each engine, not after assembling all the engines. These are the general procedures for overhaul. Each step contains various cautionary requirements that must be met. Now, let's look at the procedures in detail, step by step. To find the cause of any engine defect, you must have an accurate understanding of the type of defect. This will enable you to decide which parts of the engine should be disassembled and inspected. Different parts must be disassembled, depending on whether the defect is electrical or mechanical. It must also be determined whether the engine should be overhauled in place on the vehicle or dismounted from the vehicle. The method of defect condition assessment procedures vary depending on the type of defect. If the compression pressure is low, for instance, check whether the pressure is low for all cylinders or for one cylinder only. Whether or not the pressure rises when oil is injected through a spark plug hole. And whether or not cooling water bubbles in the radiator when the engine speed is increased. If the exhaust is white or bluish-purple, oil loss via a piston ring or a valve guide is likely. In such a case, check whether or not the exhaust is a vapor. and whether or not the spark plug is soiled with carbon or wet with oil. This will enable you to narrow the range of suspect parts, saving time and labor and minimizing mistakes. Be sure to understand the engine's condition before disassembling. The 4AF gasoline engine is composed mainly of these parts. You will learn the specific procedures for disassembling 3 sections of the engine: the timing belt, the cylinder head, and the cylinder block. First, how to remove the timing belt. First, loosen the alternator and remove the drive belt and water pump pulley. Then, remove the spark plugs using an appropriate SST. For each cylinder, check the spark plug for carbon deposits and signs of burning. Remove the cylinder head cover. Turn the crankshaft in the running direction to align the timing marks on the camshaft timing pulley and crankshaft timing pulley. Position the number 1 cylinder at compression top dead center. Remove the crankshaft pulley using 3 different SSTs. First, loosen the crankshaft pulley bolt, then remove the pulley. Remove the timing belt covers and timing belt guide. At this time, with chalk or a similar marker, draw an arrow showing the rotating direction on the rear side of the timing belt and idler pulley. This enables keeping the same fit of the timing belt. Loosen the idler pulley bolt. Loosen the timing belt and temporarily tighten the bolt. Then remove the timing belt and idler pulley. Be careful not to bend or twist the timing belt excessively. Do not allow the belt to come into contact with water, oil, or steam. Remove the crankshaft timing pulley and camshaft timing pulley. This completes removal of the timing belt. Next, the cylinder head is removed. Remove the distributor, water pump, alternator, carburetor, and manifolds in advance. Measure the camshaft thrust clearance. To do this, attach a dial gauge vertically to the camshaft end and move a screwdriver back and forth in the clearance. The standard clearance values are shown here. If the clearance exceeds the maximum permissible value of 0.11 millimeters, replace the camshaft or the cylinder head. Remove the intake and exhaust camshafts. Turn the intake camshaft until the service bolt hole comes to the top. With the service bolt hole in this position, the number 1 and number 3 cylinder cam lobes will push their valve lifters evenly, minimizing the load from the valve. Then remove the number 1 bearing caps of the intake and exhaust camshafts and remove the oil seal. Holding the intake camshaft with a wrench, secure the subgear to the driven gear with a service bolt. Remove the intake camshaft bearing caps in this order: number 5, number 2, number 4, and number 3. To remove the bearing caps, uniformly loosen the bearing cap bolts little by little. For the number 3 bearing cap particularly, loosen the bolts very carefully, little by little, in several passes, so that excessive force is not applied to the thrust portion. To remove the subgear by removing the intake camshaft, mount the hexagonal wrench head portion of the camshaft to a vise using a protector made of aluminum or the like. Insert 2 bolts in the service holes of the camshaft subgear as shown. Inserting a screwdriver between the 2 bolts, remove the service bolt while removing the camshaft. Remove the snap ring using an SST. Remove the wave washer, subgear, and camshaft gear spring. Since the subgear is retained by the camshaft gear spring, be sure to fix the subgear with a service bolt. Then remove the camshaft. To measure camshaft gear backlash, reinstall the intake camshaft with the subgear removed and the bearing caps on the cylinder head. Moving the camshaft, measure the backlash with a dial gauge applied vertically to the teeth surface of the exhaust camshaft gear. The maximum permissible backlash is 0.3 millimeters. Turn the exhaust camshaft so that its knock pin comes to the position shown, allowing the number 1 and number 3 cam lobes to push their valve lifters evenly. Remove the exhaust camshaft bearing caps in this order: number 5, number 2, number 4, and number 3. When removing the number 3 bearing cap, loosen the bearing cap bolts little by little, carefully, in several passes, as with the intake camshaft bearing caps. Now the camshafts have been removed. During these procedures, be careful not to apply excessive force to the camshafts or damage the thrust portion on the cylinder head side with a tool or other object. This could cause problems such as camshaft seizure or breakage after the engine is reassembled. Now the cylinder head's removed. Using an SST, loosen and remove the 10 cylinder head bolts in this sequence. Then remove the cylinder head and gasket, taking care not to scratch the cylinder head and cylinder block surfaces. Disassemble the cylinder head. First, remove the valve lifters. Using an SST, release each valve spring retainer lock. Then, remove the valves, valve spring retainers, compression rings, and valve spring seats. Remove the oil seals. This completes cylinder head removal. Now let's look at the procedure for removing the cylinder block. First, disconnect the oil pan from the cylinder block using an SST. Then remove the oil strainer, the oil pump, and rear oil seal retainer. Measure the connecting rod thrust clearance with a dial gauge attached to the connecting rod cap. The standard thrust clearance is 0.15 to 0.25 millimeters, and the maximum permissible clearance is 0.30 millimeters. If the clearance exceeds the maximum value, replace the connecting rod with a new one. Before disassembling the cylinder block, stamp a match mark on each connecting rod and bearing cap. For example, stamp 1 mark on the number 1 connecting rod and bearing cap, 2 marks on the number 2 connecting rod and bearing cap, and so on. This helps ensure correct reassembly. Remove each bearing cap and place a short vinyl tube on each connecting rod bolt so that bolts do not scratch the cylinder bore surface. Carefully remove the piston and connecting rod assemblies from the cylinder block. Before removing the crankshaft, measure the crankshaft thrust clearance with a dial gauge. The standard clearance is 0.20 to 0.22 millimeters, and the maximum permissible clearance is 0.30 millimeters. If the clearance exceeds the maximum value, replace the thrust washers. Remove the crankshaft. Gradually loosen and remove the crankshaft bearing caps in this order. Then remove the upper bearings and thrust washers. Arrange the removed bearings, bearing caps, and thrust washers in order so that they can be reinstalled in their correct positions. Here, let's look at the method of measuring the oil clearance of each crankshaft bearing. Install the upper bearing on each bearing cap, aligning the oil holes. Place the crankshaft on the cylinder block. After cleaning the journal bearing with waste cloth, set a piece of plastic gauge axially on the crank journal and install the bearing cap. Apply a thin coat of engine oil to the threads and bearing surface of each bolt. Do not turn the crankshaft during measurement. The cap tightening torque is 610 kilograms per centimeter. Remove the bearing cap and measure the width of the plastic gauge at the widest portion. The standard oil clearance is 0.015 to 0.033 millimeters, and the maximum permissible clearance is 0.10 millimeters. If the oil clearance exceeds the maximum value, replace the bearings. Also, measure the oil clearances of the connecting rod bearing and camshafts using the same method, using plastic gauge. Finally, disassemble each piston and connecting rod assembly. Remove the piston rings using a piston ring tool. Using 4 different SSTs and a press, remove the piston pin from each piston. To do this, set the SSTs at these positions to ensure that the load is applied vertically to the piston pin. Never pry the piston pin, or it could become unremovable. Slowly and carefully apply pressure to remove the connecting rod from the piston. This completes cylinder block removal. Be sure to arrange all removed parts in the correct order to save labor and time in later reassembly, as well as to avoid incorrect reassembly. Place the removed parts on a parts stand or arrange them in order with a numbered slip on each part. Return each removed machine screw or pin to the part from which it was removed. Disassembled parts must also be cleaned. Check each part for carbon deposition and flatness and clean it. If parts are inspected without cleaning, it is difficult to find defects. In addition, foreign matter may adhere or enter during inspection, adversely influencing the performance of the reassembled engine. Washing and cleaning are extremely important in maintenance work. Now, let's look at the inspection methods. As advised earlier, you must inspect parts as they are removed. You will waste time if you parts after disassembling the engine completely. Master the inspection method so that you can inspect parts while removing them. Let's begin with inspection of the timing belt. Visually, thoroughly inspect the removed timing belt. If the belt is broken, improper installation is the likely reason. Cracking or damage to belt teeth indicates camshaft seizure. Cracking or noticeable wear of the belt face indicates timing belt idler seizure. If any of these defects is found, inspect the parts suspected of causing the problem. The cylinder head and the cylinder block are inspected at the same time. First, check the cylinder head and cylinder block for cracks and damage. If the cooling water level is abnormally low, or if the engine oil is opaque, damaged parts are likely. Check for cracks and other damage visually or with a dye penetrant. Cracks appear as red lines like these. Similarly, check each connecting rod and the crankshaft for cracks and damage. Next, inspect the cylinder head and cylinder block surfaces for deformation. First, measure cylinder head surface warpage on the combustion chamber side at the 6 positions shown, using a thickness gauge and a steel precision straight edge. The maximum permissible warpage is 0.05 millimeters. Also, measure surface warpage on the manifold side. The maximum permissible warpage is 0.10 millimeters. Next, measure cylinder block top surface warpage. The maximum permissible warpage is 0.05 millimeters. For any of these surfaces, if warpage exceeds the specified maximum value, grind to correct it or replace the part. If compression pressure is abnormally low or there is oil loss via the valve guides, the valves must be inspected. First, check each valve face and stem for damage and streaking. Then, measure the overall length of each valve. The minimum permissible length is 90.95 millimeters for the intake valve and 91.40 millimeters for the exhaust valve. Also, measure the outside diameter of each valve stem. The minimum permissible diameter of the stem is 5.930 millimeters for the intake valve and 5.925 millimeters for the exhaust valve. If any of these measurements is smaller than the specified minimum value, replace the valve. Using a caliper gauge, measure the inside diameter of each valve guide stem. This measurement must be taken in 2 directions at a total of 6 positions. The standard inside diameter is 6.01 to 6.03 millimeters. If the measurement exceeds the standard range, replace the valve guide stem. If there are no abnormalities in the valves and valve guide stems, inspect the valve seats. Valve seats should also be inspected after valve replacement. Apply a thin coat of red lead primer to the valve face. Lightly press the valve against the seat. Then check that the seat contact is at the middle of the valve face in a constant width along the entire circumference. The standard contact width is 1.0 to 1.4 millimeters. If the contact width is outside this standard range, correct the valve seat. If the cylinder head makes an abnormal noise, the camshafts must be inspected. This inspection must also be carried out whenever the cylinder head is disassembled for overhaul. First, check each camshaft for circle runout using V-blocks and a dial gauge. Circle runout can be determined from the deflection of the dial gauge. The maximum permissible runout is 0.04 millimeters. If this maximum value is exceeded, replace the camshaft. Next, measure the cam lobe height with a micrometer. The standard height is as shown. If the height is smaller than the minimum permissible value, replace the camshaft. Wear on the cylinder inside wall can be determined from the compression pressure measured before disassembly. Normally, the cylinder inside wall tends to wear more in the upper portion, especially in the piston thrust direction. If a piston ring is broken and seized, or if the engine overheats, the cylinder inside wall can be damaged or seize up. It is necessary to check the cylinder bore wall for wear and damage. Using a cylinder gauge, measure the cylinder inside diameter in the upper, middle, and lower portions, each in 2 directions, for a total of 6 positions. Subtract the minimum measurement from the maximum. If the difference is greater than 0.2 millimeters, bore the cylinder. If the engine overheats, or if the crankshaft does not rotate, each piston must be checked for damage and deformation. First, using a micrometer, measure the piston outside diameter. With the piston upside down, measure the piston diameter in the thrust direction, 38.5 millimeters from the piston's bottom edge. Subtract this measurement from the minimum cylinder bore diameter measured in the thrust direction. If the difference exceeds the permissible range of 0.06 to 0.08 millimeters, replace the piston or the cylinder block. If oil consumption is high due to oil loss via the piston ring, or if compression pressure is low, check each piston ring for damage, wear, or seizure. The clearance between each piston ring and ring groove must also be measured. Insert a thickness gauge into the ring groove through the gap between the ring and the groove wall and measure the clearance along the entire circumference. Also, measure the piston ring end gap with a thickness gauge. For measurement in the cylinder bore portion with the least wear, use a piston to push the piston ring into the cylinder bore to an 87 millimeter depth from the cylinder block's top surface. Now the crankshaft will be inspected. First, inspect the crank journals and pins for damage and seizure. Then, using V-blocks and a dial gauge, measure the circle runout of the crankshaft. The circle runout can be determined from the deflection of the dial gauge as the crankshaft is rotated once. The maximum permissible runout is 0.06 millimeters. Using a micrometer, measure the crankshaft diameter at these journal and pin positions. Calculate out of roundness and taper. At both journal and pin positions, the maximum permissible out of roundness and taper values are 0.02 millimeters. If there is conspicuous streaking or seizure on the crankshaft, or if circle runout or uneven wear exceeds the specified limit, replace the crankshaft. You have studied the major inspection methods of disassembled parts. Various other inspections may be required depending on the problem. Master proper inspection methods with reference to the repair manuals. After the disassembled parts have been inspected and corrected, they are to be reassembled into an engine unit. In reassembly, check each part carefully for foreign matter. Clean the rear side of each bearing to remove dust and grease. Using compressed air, remove foreign matter from each oil hole and bolt hole of the cylinder block. This video will show the specific reassembly procedures for 3 sections: the cylinder block, the cylinder head, and the timing belt. Let's begin with piston part assembly. Using 5 different SSTs and a press, join each piston and connecting rod. Be careful not to deform the piston. Align the front marks of the piston and connecting rod. Install bearings in the connecting rod and bearing cap. At this time, be sure to install the correct bearings matching the numbers. Install piston rings using a piston ring tool. Be careful to install the correct piston rings. At this time, ensure that the front mark of each piston comes at the front and that the piston ring end gaps are positioned as shown. Next, crankshaft parts will be installed. Aligning the oil holes, install the upper bearings with oil grooves on the cylinder block. Install the lower bearing in each bearing cap. Also, be sure to install the correct bearings matching the numbers. You can select the correct bearing this way. Add the numbers stamped on the cylinder block to the number on the crankshaft and select a bearing having the same number as the sum. In the present engine, for example, 2 is stamped on the cylinder block and 0 on the crankshaft for the number 2 main journal. 2 and 0 make 2. Therefore, the appropriate bearing number is 2. Correct bearings for other cylinders can be selected in the same way. Install the upper thrust washers on both sides of the number 3 journal of the cylinder block with the oil grooves facing outward. Lubricate the bearings in the cylinder block with engine oil and install the crankshaft. Then, install the flanged lower thrust washers on both sides of the journal of the number 3 crankshaft bearing cap with the oil grooves facing outward. Set the bearing caps in numerical order with the arrows facing the front. Apply a thin coat of engine oil to the threads and bearing surface of each bearing cap bolt and temporarily tighten the bolts little by little in several passes. Then tighten bolts to the specified torque, 610 kilograms per centimeter. After that, check that the crankshaft turns smoothly. Install the piston and connecting rod assemblies. First, lubricate each cylinder bore and piston with engine oil. Be sure to lubricate the crank pins as well. Using a piston ring compressor, push each piston and connecting rod assembly into the appropriate cylinder. Place a short vinyl tube on each connecting rod bolt to prevent damage to cylinder inside wall and crank pin. Install a bearing cap on each connecting rod with the front mark facing forward. Temporarily tighten the bearing cap nuts uniformly, little by little, in several passes. Confirm that the mated bearing cap and connecting rod have the same match mark, which was stamped in disassembly. Tighten the nuts to the specified torque of 500 kilograms per centimeter. Measure the connecting rod thrust clearance. Then check that the crankshaft turns smoothly. Now, let's look at the method of installing the cylinder head. Removed gaskets and oil seals must all be replaced with new ones. Prepare new gaskets and oil seals before beginning cylinder head installation. First, install the oil seal, valve, spring seat, valve spring, and valve spring retainer in the cylinder head. Using an SST, install the valve spring retainer lock. Lightly tap the valve stem top with a plastic-faced hammer to ensure a proper fit. Install the valve lifter and shim. Place the cylinder head gasket on the cylinder block in the correct orientation and on the correct side. Place the cylinder head in position on the cylinder block. At this time, do not slide the cylinder head on the cylinder block because the cylinder head's bottom face could be scratched by the knock pins. Lubricate the cylinder head bolt threads with engine oil and set the bolts in the bolt holes. Using an SST, tighten the bolts little by little in this sequence in several passes. The specified tightening torque is 610 kilograms per centimeter. For a 4AFE engine, the method called yield point fastening is used to tighten the cylinder head bolts. First, tighten the cylinder head bolts to the specified torque of 300 kilograms per centimeter using an SST. After tightening the bolts, mark each bolt head with paint at a point toward the cylinder head front as shown. Then turn the bolts 90 degrees and another 90 degrees in this sequence to retighten. Cylinder head bolt tightening is complete when the front mark on each bolt head has been turned 180 degrees from the original position. Next, install the exhaust camshaft on the cylinder head, taking care of the knock pin position. Apply seal packing to the number 1 bearing cap of the exhaust camshaft at the position shown and install the bearing cap in the proper position on the cylinder head. Install the remaining camshaft bearing caps on the cylinder head and tighten the bolts to a torque of 130 kilograms per centimeter in this sequence. Apply MP grease to the entire lip circumference of a new oil seal. Using an SST, insert the oil seal as deeply as possible into the cylinder head. Rotate the exhaust camshaft so that the installation mark is positioned as shown. Install the intake camshaft according to the installation mark. Install the number 3 bearing cap. Carefully tighten the bearing cap bolts little by little in several passes. Install the remaining bearing caps in this sequence. The specified tightening torque is 130 kilograms per centimeter. Remove the service bolt that fixes the subgear and tighten the bolts of the number 1 bearing cap. This completes installation of the camshafts. The oil pan will now be installed. Apply seal packing to the oil pan continuously. For the bolt holes, apply it inside. Then, before the seal packing has dried, install the oil pan on the cylinder block. Now, let's look at the procedures for installing the timing belt. Install the camshaft timing pulley and crankshaft timing pulley. Temporarily install the idler pulley of the timing belt and install the tension spring. Position each timing pulley at the top dead center mark and set the number 1 cylinder at compression top dead center. Install the timing belt in the correct direction while checking the arrow mark put on the belt when it was disassembled. Loosen the idler pulley bolt and tighten the timing belt. Temporarily tighten the crankshaft pulley bolt. And turn the crankshaft 2 times in the forward direction. Tighten the idler pulley bolt. Then check the timing marks for alignment. If they're not aligned, remove the timing belt and reinstall it. Tighten the idler pulley bolt to the specified torque of 375 kilograms per centimeter. Install the timing belt guide and timing belt covers. Using SSTs, tighten the crankshaft pulley bolt while fixing the crankshaft pulley. The tightening torque is 1,200 kilograms per centimeter. You have now learned the procedures for installing the cylinder block, cylinder head, and timing belt. For further details and tips on each installation method, refer to the appropriate repair manuals. When the engine has been reassembled, each part must be checked for normal function. Here, you will learn the minimum requirements of this check. The valve clearance must be checked first. Tighten each camshaft bearing cap to the specified torque of 130 kilograms per centimeter. Then, measure the valve clearance at the positions shown. The standard clearance is 0.15 to 0.25 millimeters for the intake valve and 0.20 to 0.30 for the exhaust valve. If the standard clearance value is not met, replace the shim using an SST and adjust the clearance. An ignition timing check is also important. Check the ignition timing using a tune-up tester and a timing light. For an EFI engine, check the idle ignition timing with the check connectors TEI and E1 linked by a check wire harness. Engine overhaul is now complete. Finally, let's review the entire workflow of an engine overhaul. Before disassembly, the engine's condition must be understood. Then disassemble the engine while inspecting each part removed. Then sort and clean the removed parts and reassemble them. Finally, each part of the reassembled engine must be checked as to function and adjustments made if necessary. Each of these steps must be carried out very carefully. Engine problems can be rather complex since they can be due to a variety of factors. The key to proper overhaul is to precisely understand the nature of the problem so that you can save labor and time and avoid possible mistakes. Improve your skill in overhaul, observing the basic rules.